So we're going to go over the key points here from Unit 3, okay? Talk about what kind of things will be on the test, that kind of thing. All right. So the first thing we went over in this unit, okay, was kind of the principles of uniform circular motion. Okay, what is it that causes, why does something move in a circle, what causes that, all that kind of thing. So in order for something to move with uniform circular motion, okay, we have to have a force that pulls it towards the center, and that produces an acceleration, centripetal acceleration, towards the center. Okay, it's moving at a constant speed, but not at a constant velocity. And it's not moving at a constant velocity because it's always changing direction. Okay, that's kind of the principles of uniform circular motion. That could be easily the kind of thing that might be tested in a multiple choice question. Okay, we looked at these formulas and how to use them. Okay, we looked at how V equals 2 pi r over t. Okay, big T being period, right? So we're looking at the circumference of the circle, that's 2 pi r, okay, divided by the time it takes to go around the circle. So it's really just V equals d over t. We also talked about how period and frequency are the inverse of each other, right? Period is seconds per rotation, frequency is hertz or rotations per second, okay, the inverse of each other, right? So all formulas that you'll obviously have to be able to use on the test. All right, we talked about unbanked corners. We talked about masses on strings, okay? We talked about like artificial gravity. All of that stuff was all examples of uniform circular motion, right? So any problems that we solved in class, you can expect to have to solve on the test. Right, so expect that you're going to have, you know, like an unbanked curve problem. What keeps you in an unbanked curve? Friction. Okay, so friction is providing the centripetal force. Expect a bank curve, because we went over those as well. Okay, expect an artificial gravity question. Okay, because there's only really a few different types of problems that we actually did, okay, in this unit. So they're basically all game for the written response part of the test. I'm probably not going to put a V equals 2 pi r over t problem on the written response portion because that's too easy. But you could get one obviously in the multiple choice. Okay, so a couple of other things to remember here. Okay, we said centripetal acceleration is v squared over r. Probably not something that'll come up in the written response, but possibly something that could come up in a simple calculation for a multiple choice question. Obviously, mv squared over r is the most fundamental formula for this whole unit. Okay, it's used in basically everything we do. Okay, the other thing we have to remember is for a banked curve, okay, remember that FC, okay, is acting into the center, and it is just the horizontal component of the normal force that's being produced by the car going around the corner. Okay, you're not going to have to derive the bank curve formula. Okay, I told you that before, but you're not going to have to derive it, but you are going to have to use it. And there could be multiple choice questions that ask about the nature of a bank curve, like what force is being used to provide the centripetal force. Okay, well, it's the normal force of the corner, okay, or at least the horizontal component of it, okay, that's acting back towards the middle. Right. What did we say was the reason we wanted to make bank curves? What was their advantage over an unbanked curve? Right, you don't have to rely on friction. Okay, it guarantees a safe speed regardless of what the road conditions are, because it doesn't rely on friction. Okay. All right, and remember that the formula for bank curves is tan of theta over v squared over rg, but that'll obviously be on the front page of the test, okay, with your other formulas, okay, that are on your formula sheet. Okay, when we're talking about artificial gravity, okay, we talked about how that would be provided by having astronauts on the inside of a spinning drum, okay, like you see here, right? So the drum is spinning around and around. Their inertia wants them to go this way, but the normal force of the drum pushes them back towards the center, makes it feel like there's gravity, even though there isn't. Okay, gravity would obviously diminish quickly as they moved away from the outside edge of the drum. Okay, if they got to the middle, then they would be in zero gravity again. All right, and then when we looked at that, we said that was mv squared over r, and we wanted that to be provided by the normal force, but we wanted it to feel like gravity, so it ended up being mv squared over r equals mg. All right, and then the masses cancel. Why did the masses cancel? Besides, it's on both sides. Should everybody in there feel the same? Yeah, they should feel their earth weight, regardless of their mass. They should feel their earth weight, which is why mass cancels, okay? Because it should have the same effect on any mass that's inside. Okay. All right, then after that, we talked about vertical circular motion. Okay, vertical circular motion is the non-uniform stuff, and that's where we looked at how you could have a feeling of apparent weightlessness or feel really heavy depending on where in the circle you were. Okay, where in a vertical circle are you going to feel the heaviest? Okay, at the bottom, on the inside. Okay, on the top, you can feel weightless in either position on the top, can't you? Okay, going over the top or going under the top. Either one could produce a feeling of apparent weightlessness. Okay, if I'm going under the top, I would feel weightless if I'm going the special term for it. Okay, if I want to go under the top of a vertical circle, I have to go a certain speed. What do we call it? Ooh, guess we better study that one. Okay, there's a certain minimum speed that needs to be reached. If I don't go that minimum speed, what will happen? You fall out. Okay, but if I'm going just that minimum speed, then I don't push on the track and the track doesn't push back on me, so I feel weightless. If I go any faster than that, then I feel heavier than normal. If I go over the top of a vertical circle, I'm always going to feel either equal to my normal weight or lighter. Okay, if I go fast enough, I will lose contact with the track and I will feel weightless. Okay, so make sure you go over the different situations. There's really only three. Okay, bottom on the inside, top on the inside, top on the outside. Those are the only three we dealt with. What's the main formula that we use for all vertical circular motion? Fc equals forces in minus forces out. Got to remember that. Essentially just calculating net force. Okay, but we have to remember that that's the formula we use when we're talking about non-uniform circular motion. So here's all the situations we dealt with. Okay, at the bottom of the vertical circle, gravity acts down. Well, it always acts down, but in this case it's out. Okay, and normal force, or if it's a mass on a string, tension is acting back into the middle. If I'm at the top of the vertical circle, then I have the force of gravity acting in, and if I'm going faster than the minimum speed, I would also have normal force acting in, making me feel heavier. All right, if I am going over the top of the vertical circle, gravity still acts in. It acts in for both positions on the top, but normal force now acts out unless I'm going fast enough that it's not present. Right, so those are the things we have to be able to solve. I guarantee you there's a vertical circular motion problem on your unit exam. Okay, other thing we have to remember in case that term comes up, apparent weight is normal force. Okay, we don't want to get confused as to what force that is. There's real weight, that's Fg, and then there's apparent weight, which is Fn, the force you feel. Okay, after vertical circular motion, then we talked about universal gravitation. So Newton's universal law of gravitation, okay, tells us the relationship between mass and separation distance and the force of gravity. So the more mass there is, the more gravitational attraction there will be. The greater the separation distance, exponentially less gravitational attraction, okay, according to Newton's formula. Okay, so Fg equals big G times the two masses divided by r squared. Yep. Here? And. There's a name for that symbol, but it's and. Ampersand, right. Okay, there will be a force of gravity written response problem related to calculating net force. on the unit exam. We did a few like that when we were looking at like the positions of the Earth, Moon, and Sun and calculating the net force of gravity on the Earth. Okay, we did a few like that. And then right after that, we talked about satellite motion. And the basis for all satellite motion is that the force centripetal is provided by the force of gravity. Okay, but in this case, it's Newton's universal law of gravitation, not m times g. All right, so it's Fc equals big G times m1 times m2 over r squared. Okay, we did a whole bunch like that. You guys didn't have any trouble with those. So, okay, just make sure you know how to do it, because there's also one of those on there, and it'll probably involve you having to substitute. Okay, then we had Kepler. Okay, for Kepler, be able to do multiple choice questions for him, okay, about what he did. All right, so he has 3 laws, right? The law of elliptical orbits, law of equal areas, law of periods. So easy multiple choice question, which of the following would Kepler not agree with? Okay, something like that. So make sure you know those. Okay, remember the term astronomical unit. How far is an astronomical unit? Right, distance between the Earth and the Sun. 1.5 times 10 to the 11 meters. Possibly. That's why I just said you should definitely know what they are, just in case. Okay, and then obviously you have to know the law of periods. There may or may not be an opportunity for you to use the law of periods on the unit exam. It'll depend on how the satellite motion question goes. Okay, maybe I give you enough information to use it, maybe I don't. You'll have to figure that out. Okay, also know Cavendish. Okay, we talked about Cavendish when we talked about the universal law of gravitation. He's the guy that built the torsion balance, okay, in order to calculate the universal gravitational constant. That was a very important contribution. There could probably be a multiple choice question about him. That's right. Yeah. Yeah. And guys, it's a good question, because that comes up often. If I tell you the distance between the Earth and the Sun is this much, that's center to center. Okay, always assume if it says distance, it means separation distance. The only time you have to worry about it not including the radius of the Earth is if it says above the surface, altitude, or height. Then you'll have to add it on. Otherwise, assume it gives it to you. Okay, and then lastly, we talked about gravitational field strength. Whoop. Okay, so gravitational field strength is the rate of attraction in meters per second squared or newtons per kilogram. Remember that that is different than the force of gravity. Okay, if we're calculating gravitational field strength, we are calculating the acceleration due to gravity, not the force of gravity. Okay, and this is just showing you how we derived that yesterday. Okay, so no big deal on that. We're just canceling the smaller mass. So you can't read my writing? Which part? Yeah, t squared over r cubed equals k. Right. Here, law of periods. Yeah, that's a p. Yeah, it kind of went into my e there. And this is Cavendish discovered big G, not 6. Yeah. Yeah. All right, so I've written apparent weight is Fn on here twice. I probably use the term apparent weight a lot on the unit exam, I would imagine, since I wrote it on there twice. Okay, so make sure you understand that one. Okay, and then remember this, because we just talked about it. Remember, if it says surface, altitude, or height, okay, that you may have to add or subtract the Earth's radius depending on the situation. If they give you the height, then you'll be adding the Earth's radius on. If they ask you to calculate the height, you'll calculate the radius and then subtract the Earth's radius from that. Okay, so just remember, that's one of those things where it's a 5-mark question and it's asking for the height above the surface, and you forget to do that, it's 2 marks. And you'll lose 2 marks because you won't have the right answer, and you'll be missing the step where you subtracted or added. Okay, and you don't want to do that. So make sure you're looking for that term. Okay, be on the lookout for it. That's it. Okay, that's well, it's not as much as your other tests have been. Okay, there's really only a few types of questions, right? You're going to have an unbanked curve, a banked curve. You're going to have an artificial gravity question, gravitational universal gravitation question, a satellite question, gravitational field strength question, and what did I miss? Something else. Can't remember what now. Okay, but oh, vertical circular motion question. There's your 7 problems. Okay. Hey. Oh, because what we were doing here was we said that m times g equaled big G times m1 times m2 over r squared. So if I was calculating little g, I divide both sides and the smaller mass cancels off. Yeah? All right, you're not going to have to derive that formula because it's on your formula sheet. All right, so that's what's on there. I'll give you the numbers here for the other. All right, you have 15 multiple choice questions. Okay, 15 multiple choice. All right, and we've talked about how those are going to be, the fundamentals of circular motion, maybe some stuff about banked and unbanked curves, just the fundamentals of them. Okay, there's going to be some questions about, universal gravitation and satellite motion, all understanding stuff. Okay, in fact, there's no calculations in the multiple choice, not a single calculation. Okay. So they're all understanding stuff. And then, like we said, there's 7 written response problems, 1 of each kind that I told you. Right, so you know exactly what will be on there. Okay, this is the shortest of your unit exams by a considerable margin. I think it's 12 marks less than your dynamics test, and it's 16 marks less than your kinematics test. So it is the shortest of all the tests you'll write for me. Okay, now that does not mean slack off. It means study harder for this one than you did for the others so you can boost your exam mark. Okay, you should be able to do better on this one than you did on the others. Okay, looking at some of the circular motion assignments that I got yesterday, I marked them last night. You should do better on this test because from what I saw, you know this stuff a lot better, at least the first few that I marked anyway, would say that given how many times I wrote 60 out of 60 on the score. Okay, so study hard for it. Make sure you can do these kinds of questions. Then nothing will surprise you. And you shouldn't get pressed for time. Okay, you really shouldn't, because this is 12 marks shorter than your dynamics test and 16 marks shorter than your kinematics test. So it is quite short. Okay. In fact, I gave a similar test to this one, obviously not exactly the same, second semester of last year, and I had all but 2 of them marked before the class was over. Okay, like everyone had handed them in and I had marked them. Granted, there were only 14 people in the class, but okay, it said that most people were done by like halfway through the class. Okay, so make sure you study well for it, and you shouldn't find it too taxing. All right, is there anything you guys want me to go over in more detail, or anything you want me to review a little bit more from this unit? Stuff at the start. Okay. Further back in your memories. Okay, the stuff that you just handed in to me on the circular motion assignment. Yeah, so you actually just did a whole bunch of. Okay, anyway, we'll go over it. It's no problem. Okay, so bank curves, unbanked curves. Okay, just remember, okay, for the unbanked curves, FC is going to equal the force of friction. All right, so we're going to have mv squared over r equals mu times the normal force. But since the corner's not banked, it's level. Normal force is equal to? Not friction, force of gravity, right? So you have mu mg here. All right, so an unbanked curve question is only going to ask you to calculate either the coefficient of friction, the radius of the corner, or the speed of the vehicle. Okay, it's not going to ask you to calculate mass because mass is irrelevant. It's going to cancel when you do any manipulating anyway. All right, so basically just simple manipulation. And that's the nice thing about this unit is there really, I mean, other than, yeah, when you have big G times M1 times M2, there's lots of things to move, but everything's divide. You know, it's easier stuff than it was before. Okay, for the bank curves, okay, so you got tan of theta equals V squared over R times G. So really all you could ever be asked there would be radius of the corner, how fast you could take it, or what's the angle of bank. All right, the angle of bank's probably the trickiest one because you got to remember to inverse tan whatever you get. Okay, other than that, they shouldn't be too trying either. And that one you never set equal to anything else. It's just that formula. It only does that one job. Okay, and then artificial gravity. Okay, we kind of talked about it already. FC, we want to have it equal to the force of gravity. We want to feel like we're at home. Okay, so mv squared over r equals mg. Okay, and like so many of the problems we've dealt with, most of the time when we're solving for v, it's v equals rg or gr. Okay, if it's gr. Right. It came out to that a lot of times, especially in vertical circular motion. It came out to that a lot as well. Okay. Anything else? Okay, so your best bet here, guys, for things to use to prepare, obviously the review package I gave you, right? It has a bunch of problems on it that you can try that are old exam problems, so they're exactly the kind of thing I'll ask. I will hand back your circular motion assignments on Monday. Use those too, because obviously it'd be similar to questions you did on there. And then stuff that's on your gravitation assignment or like gravitation worksheets. Okay, you have in the worksheet booklet, you have 6 satellite motion problems. I don't think we got through all of them in class, but they'd be good to do. Okay, and we had a couple of gravitational field strength problems. Worth it to do those as well. Okay. All right, anything else you guys want me to go over specifically? Okay, well, if some more questions come up, just ask. But until then, I'd like you working on the review package, which I posted last week in Google Classroom. Okay, we'll just pull that up here. Okay, so it's here, guys. It was on December 3rd that I posted that. Okay, if you click on that, yep. Okay, you'll see here's your review package. So it's got some of the stuff that I went over just now, but typed out a lot neater than I wrote it, obviously. Okay, and then some suggestions there, and then there's the formula that you'll get, and then here's some of the review problems. Okay, so there's a unbanked curve, unbanked curve, bank curves. Okay, there's some of everything. Like I say, they're all old exam questions, so they're all worth doing.